Today I'm going to demonstrate how I 3D print bolts using less filament, but yielding a higher strength finished product. Now, this isn't the traditional style for 3D printing bolts, so make sure you pay attention, and as a bonus at the end, I'll even share how I'm able to print these bolts out without support material to keep the material use to a minimum. Usually, threads are 3D printed vertically because it's an easy orientation to print, and while this may be okay in some cases, it doesn't give us the best strength because the layer adhesion strength becomes the bottleneck. It's very easy to pull the layers apart in comparison to stretching the layers apart. Igor from My Tech Fun made an entire video about 3D printing threads for the maximum strength, and this video is going to demonstrate how to design a bolt with this in mind. I'll demonstrate this in Shapr3D. The first thing that I do is create a circle sketch with the center of the circle being on axis. I give the end of the bolt a slight bevel, then I jump to the perpendicular plane to design the thread portion. I sketch out a square shape to create a 45-degree thread angle. Then I rotate the sketch by 45 degrees and arrange the square so that the diagonal cross section is beyond the boundary of the cylinder that I've created. I then move this square sketch down so that way the soon-to-be threads will cover the entire length of the cylinder. Then I select the square sketch and the axis the cylinder is centered on. I select the revolve tool, which creates a thread-like shape that I can extend beyond the length of the cylinder. Then I can adjust the pitch, which is usually a higher number, and normally I start with 9,000. Then I select the cylinder and the threads and use the subtract tool to create the threaded bolt shape. I can then give this bolt a little shimmy to the left and create the hex head portion. The circle sketch is still chilling where I left it, so I can use the polygon tool to create a hex head shape and overlap the circle sketch. I then select the circle and hex shape and extrude it to create the hex head portion of the bolt, and I change the defined parameter from subtract to union. For added touch, I'll give the head of the bolt a little bevel. I then move this bolt directly down the same axis so I can create the nut. I then move the nut down axis and create a duplicate of the bolt. For added touch, I'll give the head of the nut a little bevel. Next, I'll select the second bolt, and using the scale tool, I'll increase the height and width by 6%. Now keep in mind, how much 6% actually is depends on the size of the bolt that I'm working with, so as long as I do my math to figure out my tolerances, I should be good. Then I can move the nut over the threaded portion of the enlarged bolt and hit subtract. This is now what the cross section looks like. But now I need to split this bolt at the inside thread diameter so that way this can print horizontally and without supports. Using the innermost point of the square sketch that I used to design the threads, I can create another sketch that envelops the outside portion of the bolt and intersects the bolt at the inside thread diameter. I can then move this sketch to a higher plane and subtract this entire sketch from the bolt design to create the exact result that I'm looking for. Now I'm going to demonstrate how I slice this for 3D printing. In Bambu Studio, I'll split the objects apart and then I'll orient the nut and bolt so they're printing face down and horizontally. This gives the bolt the most strength it can have, and it allows us to use the least amount of material possible. If you found any part of this video useful, I welcome you to the easiest way of letting me know, which is leaving a like and maybe sharing your thoughts in the comments. If you have any questions or comments about this process or what you want to see next, share it in the comments below. But that's all for today. Thanks for watching, and I'll see you next time.